Hi. A very important part of how the tree grows is based on the soil. It's really interesting to study the geology first. Here's a rock. Study the geology first, which is the material that weathers, that creates the soils. So soils are different all over the world and they're different all over Colorado. And it has a lot to do with what trees grow and how well they grow. So let's study soils for a little bit. This is a demonstration I would do in class. We'll just call this amateur hour today. And I'll teach you about the soils and then I'll show you about it. So I'm going to disappear for a little while and talk about soils. And the first thing you need to know is that 100% of the soil material is divided into around 25% air particles, 25% water particles, 45% broken down rock material we refer to as soil particles or mineral particles, and anywhere from 0 to 5% organic matter. The organic matter is what makes the soil rich, good for agriculture, good for growing trees, and varies obviously depending on the conservation practice as well as the soil type. Now, if a soil has too much air in it, then it doesn't have enough pore spaces for water. And if it has too much water in it, it doesn't have enough pore spaces for air, and it's considered saturated. So that's one thing you'll see in a minute. So the definition is that forest soils are a thin layer of mineral and organic matter, and they vary depending on age, the rock, the vegetation, and the organic matter. And they're characterized by the organic matter, which retards runoff, holds water, lessens the temperature and moisture extremes. A soil profile is when we look at a road cut when we're driving by, or we dig a soil pit, or we watch a house that's being built and we see them building the basement. And what you'll have is the A horizon, the B horizon, and the C horizon. And each of these three horizons will be at different depths. And on the top will be the duff or the humus layer. Leaching is the process by which the water percolates down through the topsoil, carrying dissolved material with it. Again, we have the organic matter created by the roots, dying and decaying plant material and insects, the A horizon, the B horizon, and the C horizon. There's different forest soils in different places, and we can technically classify those soils. And this is one of the courses you'd like to take if you are getting a four-year degree. We teach that here at Front Range, and it transfers to CSU. So this is more into the technical soil classification, and specifically here for forestry. Soil properties are divided into 5 things: the texture, the structure, the pH, the fertility, and the water holding capacity. And those are the 5 things I'm going to demonstrate to you in a minute. So the soil texture is the size of the soil particles. Sand is the largest, silt is the medium, and clay is the smallest. So if you can imagine, clay has the least amount of pore spaces or room for air or water particles in between, which is why it binds together. The texture triangle I'll introduce to you in a minute. If you know the percent clay, the percent silt, and the percent sand, you can put those on this chart and you can determine your soil texture. The arrangement of the soil particles are the shapes that they are. And we always used to make up names for them like cheese slices and popcorn and popsicles, and you can see this when you're looking at a soil horizon. We will be doing this in one of our field trips. The soil nutrients are the nitrogen, the phosphorus, the potassium, and then the pH is what makes those nutrients available for absorption. It's the balance of hydrogen ions in the soil. It's like the chemical pluses and minuses flying around in the soil, making things available and not available by binding them up. The nitrogen makes for the green foliage like grass. The phosphorus makes for strong roots and fruits and flowers. And the healthy growth or vigor is attributed to the potassium in the soil. Those are the three major nutrients. There's many other nutrients needed in micro amounts. So a fertilizer bag has three names on it: nitrogen, phosphorus, and potassium. And so you can determine whether you want green grass, you would have a fertilizer that has a lot of nitrogen. If you want fruits and flowers or good tomatoes, you might want a lot of phosphorus. Last is pH, and the pH is important to know because it influences how easily plants can take up nutrients. Again, it stands for potential of hydrogen ions, and here's a short chart that shows that neutral is 7, acidic soils are 4s, and alkaline soils go up to 10 and higher. And this is the amount of availability that these nutrients are for the plant with these pHs. So we want something between slightly acid and slightly alkaline. You can do a soil pH test. 7 is neutral. A pH is the product of the factors which formed it. So it is made up of the organic matter. Needles and out east is more acid. Western soils are more alkaline. The productivity and site index is the ability of trees to absorb the soil, water, chemicals, and oxygen. And the site index is a term used to refer to the height dominant trees have attained at a certain age in that soil. So a site index for Douglas fir could be 150, and that is a 50-year index for dominant trees will be 150 feet tall. So site index is interesting. And not just soil, but also light and temperature, slope, and aspect. Aspect is the direction the slope is facing, like north, south, east, or west. South slopes being much drier, and north slopes being shadier and moister. And precipitation, soil moisture, has a more direct impact. So, other biotic factors are disturbances, whether they're natural or man-made, and soil erosion. And what I'd like to show you now is some demonstrations on soils. So, let's get this screen to fit and put it down on the table. This is my homemade laboratory here. A rich soil. A little bit higher. There we go. A rich soil is dark in color. And one of the things we might do is use a Munsell soil color chart. You can lift this open. You can take a sample of your soil. You can hold it behind that and match it up to the color. And you can see what hue and value you have for that soil color. So soil color is one thing that we use. Number 2, we have a soil test kit. And we would take a little bit of soil in here. We would add some reagents. And then we would shake this test tube. And if it was nitrogen, we would hold it up to this and see what color we get for nitrogen. We could do a second test for phosphorus, a second test, a third test for potassium, and also this is a way to do a pH test as well. So that is a small soil test kit to determine the nutrients. The way we do soil pH in the field is we use this kit, and we take a small sample of soil. We put it in a little tray here. We add some reagent to it. Two drops of reagent. Sprinkle a little powder on it. The powder will react with the soil and with the reagent, and again, we will be able to get a match of a color of what the pH for this soil is. So that's the pH. One of the things we do most commonly is the texture. Now, one way to do texture is to use a sieve. So I have a sieve here to show you. And I would take a soil sample, and I would use 3 different sieves. And this sieve is a certain size, and by shaking it, I will be able to get the percent of the soil that is of this very, very fine millimeter size particle. So for this sieve, it is 100-inch mesh. So this is 100 sieve, and I'm going to put that back in there. And the last thing I'm going to show you is soil texture. So the one way to do this is to do a ribbon test. And a ribbon test is taking this soil, take this soil, and get a little bit more. I feel like Bill Nye the Science Guy here, only he has probably professional film crews, or I know he does. Moisten just a little bit of this water till it forms a ball. And then you'll do what's called a ribbon test. So I'm moistening this ball. Now think about sand, silt, and clay are the 3 textures of soil. And if I make a ribbon by squeezing my thumb and my index finger together and it sticks together, would it be sand, silt, or clay? It would be clay. If it forms a little bit of a ribbon and then breaks, it would be silt. And if it doesn't form a ribbon at all, it would be sandy. All right. Another way to figure out that texture triangle is to do the jar test. Now, which one is the heaviest, sand, silt, or clay? I've taken a jar of water and I've added this very same soil to it, and it's separated into sand on the bottom, silt, and then clay with organic matter floating on the top. So looking at this, I can estimate that it's a 60% sand, it's a 20% silt, and it's a 20% clay. So now we use a texture triangle, and if it's a 60% sand, we go up this way. 60% sand, 60% silt, nope, 20% silt, and here we go. 60 sand and 20 silt. Using this texture triangle says it's a sandy clay loam. So this is the texture triangle. This is the way we determine textures of soils. And so we've talked about pH, color, nutrients, and soil textures, and other things that you need to know. to understand soil and nutrients.